In this problem, we're given information about a very simple electric circuit. And we actually don't need to know a whole lot about electronics. Some of you probably know more about electric circuits than I do. But in this circuit, we have a battery, which will have a voltage. The current's moving in this direction through one resistor. You think about that like a light bulb. The voltage in the electric circuit below is given by the equation V equals I times R. I is the current in amps, or amperes. R is the resistance in ohms, and the voltage is measured in volts. The voltage is increasing at a rate of 1 volt per second, and the current is decreasing at a rate of 1/3 amps per second. Find the rate at which R is changing. At the moment V, the voltage is 12 volts, and the current is 2 amperes. This equation, V equals I times R, is actually a very famous equation in physics. This is Ohm's law. V equals I times R. Well, this problem I'm not going to draw a picture for because I was given it, and honestly, it doesn't help me too much. And nicely enough, I'm given the equation that I'm going to use to get my related rates equation. I want to transfer all the given information in this equation over to the next board. So I have V equals I times R. I'm given the rate of change of voltage, dV dt, and the rate of change of current, di dt. I'm asked for the rate of change of R, which I'll call dr dt. So let's write down everything we know on the next board. So V is equal to I times R. The rate of change of the voltage, dV dt, is 1 volt per second. The rate of change of the current, di dt, well, I'm told the current is decreasing at a rate of 1/3 amp per second. So when I write this down, it needs to be a minus 1/3. The voltage is increasing, meaning its rate of change is positive. The current was decreasing, meaning its rate of change was negative. So when I read a problem like this, I have to be very careful that I need to pay attention to words like increasing and decreasing. They might tell me a sign in one of my derivatives. I'm looking for dr dt. I'm looking for a dr dt at a particular moment in time when the voltage is 12 volts and the current, spelling volts was hard there, and the current was 2 amps. All right, so here I have the equation V equals I times R. I'll need to take a derivative. In the last example, we were able to do some geometric trickery to get rid of a product. In this problem, I won't be able to do that. V equals I times R. This is the product of two functions. I and R are both changing with respect to time, so I'll have to use the product rule. The derivative of voltage with respect to time is equal to I times dr dt plus R times di dt. The first times the derivative of the second plus the second times the derivative of the first. When I really just look at this formula, all this is the formula for the product rule. I have a first function times a second function. All right, let's see if I have enough to plug in. I'm looking for dr dt. So I need things to plug in literally for everything else. I have a value for dV dt. I have a value for I have a value for di dt. And I need a value for R, and I don't have it. There is no value for R given here. But fortunately, Ohm's law itself provides that answer. At every moment in time, the voltage has to be I times R. Well, at this moment in time, the voltage is 12, and the current is 2. So I know that the resistance would have to be 6 ohms. And you can write the word ohms. We actually typically use the Greek letter omega, which looks like a little horseshoe, for that unit of measure, the ohm. So I'm ready to evaluate. dV dt, 1 volt per second. I, 2 amps, times dr dt, which is what I'm looking for, plus R. And R we just found to be 6 times di dt is minus 1/3. 1 is equal to 2 dr dt minus 2. So let's add 2 to both sides. And I get dr dt is 3/2. And let's see, this is resistance, so the rate of change would be ohms per second. Well, I should state a final answer. Instead of writing it, I'm just going to say it out loud. At the moment we're talking about, when the voltage is 12 volts and the current is 2 amps, the resistance is changing at a rate of 3/2 ohms per second. In this problem, positive meant increasing and negative meant decreasing. So more than that, if I was going to state this appropriately, the resistance is increasing at a rate of 3/2 ohms per second.